Hello, friends. Welcome to the Georgia Tech AI podcast. My guest today is Nina Moorman, a fifth year PhD student at the CORE Robotics Lab, advised by Matthew Gombolay. Nina's work tackles a deceptively simple question. If robots are going to live in our homes, how are we going to teach them what to do? She studies how everyday users break down long household tasks like cooking or cleaning the table into smaller chunks that a robot can learn and reuse over time. She pictures a future where teaching a robot is less like programming a machine and more like training a human. And now, dear friends, please welcome Nina Moorman. So, Nina, your research talks about democratizing robot learning. How can we make it such that anyone who doesn't have a technical background can teach robots in an effective way?
Yeah. The first thing I would say is you want to evaluate how accessible the current technology is. So there's been a lot of development for teaching interfaces, but not a lot of work actually evaluates it with end user populations. So the one that I spent a lot of my research focused on is older adults. But there's a wide spectrum even within that population. You could think of people with MCI, mild cognitive impairment. There's work at Georgia Tech looking at evaluating accessibility for those persons, but there's just a lot of different populations that you would want to first evaluate. How accessible is this technology? What are the pain points? What are their preferences? And then sort of continually incorporating that check-in into the design is the first way of getting there.
So, when you think about robot teaching, what are some barriers that you feel are coming up in terms of enabling people to teach robots at home like
Hmm.
they would to another person?
Yeah. So there's a lot of different ways of teaching a robot. Even at home. So the first thing you can maybe think about is how functional is the robot when it's deployed in a home? Does it come with pre-programmed functionality or does it have the ability to learn from scratch? Then you can think about if it is going to do any learning in the home, what are the forms of feedback it can take in and how will it learn and what will that look like? And so some of the common ways that you could provide feedback to a robot to teach it are what's called kinesthetic teaching. So you actually physically move the robot to show it what you want it to do. So it's a demonstration. Then there's other options. You can do it yourself and just have the robot watch you. The challenge there is that the robot is shaped, its morphology is different than what your morphology might be. And so there's a disconnect there you have to figure out how to resolve. And then there's an intermediate where maybe you move the robot with the joystick or something. And there the challenge might be that it's not intuitive what the buttons are doing and how the robot would move, especially if there's multiple arms involved. So there's different ways of then providing feedback. And even with that feedback, there's different ways of teaching from or learning from that feedback using those demonstrations. And so there's different points during the learning process, and each is very interesting and has different opportunities for accessibility.
How do we make it easy such that the whole teaching process feels natural, quote unquote, for the user? Because, you mentioned the three different modes of teaching, but I'm wondering if one takes preference over the other.
Yeah, there are definitely preferences. So you can think of preferences over different dimensions, preferences over, for example, workload, like how fatiguing is it physically and cognitively? And there maybe physically it's more fatiguing to do kinesthetic where you're actually moving the robot around. But maybe cognitively it's actually a lower workload because it's more intuitive to actually just move the robot and do what you're hoping it to do or show what you're hoping it to do rather than using the teleoperation, which might be more mental demand. Your question was, how can we make it easier? One thing that comes to mind is just teaching, training curriculums. So once you evaluate those pain points, figure out what people may need to learn. And so you can either look at how to teach the user, how to teach the demonstrator if the person that's living in the home is going to be teaching and they're not a robotics expert. So either you can improve the understanding of the human or improve the understanding of the robot. And maybe that means investigating what additional information might be in the demonstrations, injecting a little bit of knowledge about the domain or the person that would make it easier to learn in that context.
Very cool. So the two parts, that's improving the understanding of the robot and improving the understanding of the human.
Yeah.
Which part of the spectrum does your research lie in?
Hmm. I'm in human robot interaction. I look at the full interaction, and that means the two agents or more if there's multiple humans, multiple robots. A lot of my research is looking at the perception of robot learning and robot behavior from the human side. More recently, I am interested in the bidirectionality of that interaction. So improving, like I mentioned, the feedback coming from the robot to the human and from the human to the robot, and developing systems that have both those information pathways at the same time. So both ends, I would say.
I see. How does that translate into, say, some of the experiments that you've run in your lab? So I know that one of the core themes you try to tackle is hierarchical abstraction. Could you unpack that word and, help me understand why that's so important in robot learning today?
Yeah, for sure. So hierarchical abstraction. So the motivation for the question is a lot of prior work in learning from demonstrations. So that's learning from those demonstrations that you can get from non-experts. A lot of that focuses on single tasks, short tasks that you can evaluate in a laboratory setting that don't take very long to teach and don't have that many components. And I think that's a great place to start. But the reality of deploying robots in home settings, these unstructured residential settings, is that the tasks that they're going to have to do are going to have many little pieces that have to be repeated over time. So you can think of setting a table as a very intuitive one, where traditionally you might just have two people eating at a dinner table, but then they have guests and now maybe three, four people. And it's the same core actions, like setting a fork, to the right or left of the plate, depending, filling water. So these same core actions have to be repeated for multiple people. And so we want to see whether there's different ways of breaking up setting the table into tasks, into subtasks, things that have to be done. And so we want to see whether the robot is able to learn the right hierarchy of tasks in that setting.
So you're saying that when I break a long task into multiple components, it makes it easier, right, for it to adapt to, say, a different task. Is there an example where that happens?
Yeah. So I guess what I'm saying is that if you're optimizing, you could optimize for different things when providing demonstrations. One of them is just like, let me just teach quickly now this task that I'm currently doing. And so if that's like setting a table, you might just do that whole thing at once, at setting the table for two different people. But long term, you could also think about optimizing teaching time. And so if you teach in a way that breaks it down such that it can be reused later for a different number of people, if we're staying with the table setting example, then you can optimize for long-term fatigue and sort of interaction with the robot. So you can do more now in terms of like breaking it up and thinking through how you're going to teach, and that will generalize down the line. So the example we've been talking about is setting the table. You could also think of like making an omelet is another one we use in our research a lot. And so the idea is, like I mentioned, you can teach the full thing at once. So you might set 2 cups, 2 plates, forks, knives for 2 people. And that's like the goal that you currently have for setting the table. You could also then break it up and just set one person's table setting and then do that twice. So that's 2 different tasks. Or you can teach the individual pieces, maybe setting a fork to the right of a plate and then setting a plate and then calling those sort of sequenced. And so the way in which you break it up will then influence what you can use it for and how much involvement you'll have to have when you're deploying for later slight modifications in the environment or the task.
So it seems that it's beneficial for robots to learn in subtasks so that it can generalize to new tasks. Does that mean that humans also need to adapt their teaching strategies to this format? And I guess the bigger question is, do they do that naturally?
Yeah, so in some prior work that I had with Nako Gopalan, who is now a professor at ASU, we investigated first, okay, are people doing this? Like, if we have a really complex task in front of us that clearly requires repetition. So the examples in that paper were making soil mixtures for plants. So you might have different plants and some of them want more lime or more sand or more manure. And so figuring out that ratio, you might repeatedly scoop the same material. And so we wanted to see if people are faced with this task when they're teaching a robot, are they going to break it up into pieces? Are they going to do it all at once and take a really long time? For example, some of the tasks we had, I think it would take, over 9 scoops, something very long, intentional to see like, okay, you're going to break this up or not. And the takeaway we had from that first paper was people aren't really breaking it up into subtasks that can then be reused effectively. And so we actually looked at a few different metrics there. We looked at, are they breaking it up at all? And if they are they breaking it up to the amount that would be needed? And we also looked at different ways of encouraging them to break it up, the different teaching for the demonstrator, the human. And that's one thing to note, I think, is often confusing because we're talking about robot learning, but we're teaching the human. So there's the two are kind of learning here. You're teaching the human to teach the robot. So the human's becoming a better teacher.
And you see that as the major barrier, right? It's not that this will all be natural for humans to teach robots. You don't see that this whole process could be seamless. There has to be some education on the side of the human to be a better teacher.
I think it makes sense for there to exist curriculum so that if you're in the situation and it's not intuitive, then you can rely on something that isn't personalized to each person in a way that makes it intractable. So one of the things that we saw in this study was that we compared different teaching modalities. So we had that egg omelet making example, and we saw whether that would help with the soil mixing. And there was a bit too much of a difference there. It wasn't sufficient to help them breaking up. We compared videos and other teaching modalities, and we found that what seemed to be the best was just showing exactly how they should break it up, like as if the experimenter was going to do it for them and just have them essentially copy that. The issue there is that if they need to see that before they're teaching, it's not going to apply to all the tasks they're going to experience down the line. And so again, you're seeing this conflict of what will work now versus what will work long term, and how can we bridge those two? And so that was what the next work that I worked on is looking at.
Right. So you're essentially saying that for every task, it is just not feasible to show them a video of that task because, hey, there are millions of tasks. You cannot have millions of videos.
I think of how you would, teach a child. You don't want to have to explain exactly how to do every single thing before they do it. You want to show them a few examples and then for them to be able to extrapolate what are the right principles for how to do something from that. And for this case, that's how to teach a robot, how to break it up into pieces that will then help them avoid more work in the future.
How do you design a good curriculum then? Just so that there's a broad range of skills that the human demonstrators picked up on that can
Right.
generalize.
Yeah. So that's still, I think, an open question. We were first curious. So when we're saying curriculum here, what we're meaning is it possible for people to accumulate experience teaching a robot and getting some sort of feedback that isn't personalized to them? Is the combination of those two, which we call like domain experience, you can think about it as like learning from demonstration experience. Can they accumulate this so that it applies, so that they learn how to be a better robot teacher in a way that will apply to domains down the line they've never seen? So a cleaner way of saying that is that because the different curriculum that we first evaluated weren't sufficient to encourage people to provide abstractions that would suffice, we then thought, instead of showing them exactly how to do it now, let's let them practice. Let's let them try. How would they teach naturally? And then let's show them how the human expert, the experimenter, would do it. And let's see if that comparison of what they just did and what they saw someone else do would be sufficient to improve the next time. So we actually don't even let them improve or try again or change their teaching in the way that the first study did. So the difference there is the first study, before they even teach, show them what to do. And in this case, we said, okay, you try teaching. I'll show you what to do. Now let's move on to something different and let's see if you can apply what you learned. And so it kind of it encourages the teacher to try to apply to a new context the difference that they noticed there. So that's what the training curriculum looked like. It looked like sort of practice, feedback. And so we evaluated then how well people were training on these new domains. And we randomized the order of the domains so that there was no question about whether it was just this one particular series of domains that they saw in that order. And we found that it did actually help. It helped with teaching duration. So people got faster at teaching as they saw these series of domains. And they also were starting to incorporate more abstractions. So they were able to break up the task better.
So is there a Goldilocks zone where, when we don't have too many subtasks, but we also don't have too few? Is there a zone where it's optimal?
Yes. So you can think of two extremes in the abstraction level. So there can be an abstraction where they're breaking it up to such a point where they're like, move 2 inches to the right. And there's no way that's usable because you're going to have to measure. It's just not tractable. And on the other hand, there's the example we gave where it's doing the entire task in one go. And so there is definitely a space in between there. There's a definition in the paper that we have. It's essentially looking at like the minimal changes you can make so that the contact specification changes. So like maybe what that means is you can group a lot of the different things you can do together. So for example, if I'm reaching for a water bottle, that whole process is about the same until I make contact with the water bottle. And now we've got like a symbolic change in the state of the world. And so maybe you can count that as like a transition. The idea is that there's definitely a Goldilocks zone, and it probably depends on the task that you're doing. So we made rubrics, and we were able to sort of consistently evaluate the quality of the demonstrations that people were giving. And those were actually annotated by a person. So that's how we evaluated the quality for our work.
This is an open problem, but is there any room for robots to discover the abstraction themselves?
Yeah, definitely. There is some work that looks at learning the abstraction from the technology side. There's some machine learning work that does that. I think that it's still important to include the human in that process, though. Not only because the number of possible tasks are, unlimited, and the number of ways that you'd want to do things are unlimited, but there could be motivations on the human side for how they want things broken down, depending on what they want to be able to generalize and what they want to sort of keep consistent for their sake. Especially in the case of care, if you're looking at, for example, aging in place, I definitely think that it's important to at least empower people to be able to make changes to the robot's behavior if they wish to. And then you can automate whatever you're not interested in sort of being in control of. Yeah.
Let's talk about some of the ways people reacted to teaching robots. So
Mm.
one of your key findings was that people actually felt more tired when they used fewer subtasks. Can you explain why that might be?
Yeah. So some of the results can be kind of counterintuitive because it's that trade off between now and the benefit you will see now versus the benefit you will see later and the different dimensions. So if you use fewer subtasks, you might be teaching very long subtasks. Like you might be teaching go to sand, scoop, go to bin, pour. You might be teaching that like 4 times as one task. And so the physical effort, keeping track of what you're doing, moving a robot isn't always that easy. And so there's definitely a lot of effort there. Whereas if you're teaching multiple smaller subtasks, the duration is shorter. And I guess it changes what you're spending your time on. So you might be using the interface a little bit more to label the different tasks the way that you want and sort of organize them how you want, but much less continuous time actually manipulating the robot.
Are there similarities, differences that you see between how you and I as humans would teach each other
Mhm.
versus how you would teach a robot where you're breaking it into explicit categories?
Yeah, I mean, there's so many differences. I think one of the main differences is that maybe people can make assumptions about what will be understood that are more consistent for humans. You can have a dialogue and you can sort of quickly establish what your mental model of the other person should be. And that mental model is probably more static for a human than for a robot just because of the variance between how generalist the robot is, whether it understands natural language, what pre-programmed functionality it has. So I think that definitely there's just a lot more variance on the side of the robot. What they can expect can differ so dramatically.
Right.
Yeah.
And even you're one of the few studies that also evaluated personality and how, people reacted to robots based on their inherent personality traits.
Mm, kind of. There are surveys that look at the impact of personality, especially in the field of HCI, so human computer interaction, but also in HRI, human robot interaction. Yeah, there's definitely some work there that shows like that these personality traits do matter. The big 5 is what they're called. There's 5 key personality traits that the field tends to use, like neuroticism, extroversion. Sorry, it's openness, extroversion, what is it? Neuroticism, agreeableness, and conscientiousness. So there's like 5 key ones that have sort of been established in prior work in psychology that the field tends to use. And a few of them are repeatedly shown to be impactful in shaping the human robot interaction. So I think I've often seen extroversion and agreeableness be influential in shaping the interaction, like how positively the robot is seen to be, how detail oriented the human is going to be when interacting, how open minded for openness. So they definitely do influence. And it's going to be more of a post hoc analysis where you're not going to recruit to get like specifically extroverted people, but you might incorporate that as a survey when you're running the study. And then you can look after and say, okay, it's interesting if we look, there's a correlation between how much time they took and whether they're open-minded or whether they're agreeable. So that's sort of how that part of it would go.
Is there an ideal personality type?
No, I don't think so. It kind of just depends because, so for example, maybe agreeable will take longer. That doesn't necessarily mean their demonstrations are better. That might just mean that they take more time, but maybe it does. Maybe they're taking more time, so they're more deliberate. Yeah, because if you're looking for like the ideal person, ideal for what? Ideal in the sense that they're going to be most positive towards the robot, but that's not always ideal. There's a calibration there of like, you don't want them to just say everything the robot does is great because that can lead to dangerous situations.
Right. Well, okay, let's pick a metric. Let's talk about teaching quality. So, we talked about your paper talked about how agreeable people, they take longer to teach, and
Mm-hmm.
that extra time doesn't necessarily translate to improved teaching. So, where do you think that extra time is going?
I think some people just take more time. Like they're just, they enjoy the journey. They take more time doing that thing. Maybe there's also a sense of they're trying to be agreeable to the experimenter. So in a user study, it's such an interesting job because you're paying people to be there, and some people are very invested in the research, but also some people are just kind of there because it's money and it's a new experience. They don't necessarily have a stake in the research. And so they might rush through the videos. They might not necessarily watch the whole thing. They might kind of hear what your instructions are and then sort of move forward from there. So yeah, the more time might just be that, like, okay, I'm thinking through the instructions I was given. Let me really think through what I want to do and like spend the bulk of my time before I actually start teaching, or let me move slowly in case I hurt the robot. There's just so many ways in which you can slow the process down, but that doesn't necessarily mean a bad interaction, because I could definitely see cases where feeling rushed is more stressful.
Yeah, and people respond differently to time constraints.
Yeah, so it's more just let me characterize what different personality traits might experience, but not necessarily say like we're designing for any particular, or like we have a preference for any. I think it's just important to know, yeah, what characteristics would influence the interaction and in what ways as covariates. Yeah.
Yeah, a lot of your participants, I would assume, are college students,
Mm-hmm.
but you also have this focus on elder care.
Mm-hmm.
And we want the studies to be geared towards that
Yeah.
population and understand how they would respond to robots. But yeah, how do you account for this disparity? How can we make sure that, your studies are tailored to your target population?
Totally. So this is definitely a conundrum in the field. Is we want to evaluate regularly, and ideally we would want to evaluate with the end users. And there's often trade-offs between those two, like just in terms of the availability of, for example, older adults to be recruited and how much time is reasonable to ask. So in some of the studies that I've run, it's upwards of 2.5 hours. It's sort of a demanding physically and emotionally. But that said, the best practice is probably just to recruit as much as you can from target population. So often the way my studies will work is that I will recruit both from target population and from students, which is the more standard, I would say. Like the field typically recruits students because you can recruit like the next day they show up. Whereas with older adults, it's going to be a few more weeks before with scheduling and to make sure it's accessible. So I typically will recruit from both. And I also wanted to say that target population for the context of elder care isn't just the older adult. That's what makes it such a fascinating research. Is it's actually sort of a network of people. So you have the care recipient, the person that's aging in place ideally, and then you have their care network. So that's like formal and informal care providers. So you can think of formal, that's maybe more standard. You have like your doctor, your occupational therapist, physical therapist, nurse, maybe in-home care providers, but they're hired and they're sort of formally trained. And then you have informal care providers who do a lot of like the heavy lifting because they're there more regularly. So that can be family, friends, spouses. And so you're actually, I think it's important to design with all of those people in mind, the different stakeholders. And so in some of my work, I work with older adults, and then in some I work with care providers. I have had experience recruiting from the different groups there. Yeah, I think ideally you would recruit from all representative stakeholders and run a study with all of them and with a lot of them. So a lot of studies will run, 10 older adults, and that's incredible because of, the challenges with recruitment. But ideally it would be a much larger number.
I didn't think about it as a care network. That's really interesting. Do you feel that formal care providers are a bit more skeptical of robots? They have higher standards on safety?
I've never done a comparison, and I think that probably varies a lot. I have done a study where we looked at perceived performance, and there were two tasks. There was a medicine dispensing task and a banana cutting task, sort of to simulate like a breakfast scenario where you would have your medicine with the breakfast item and you would take both in the morning. And we did notice that compared to students, care providers had lower perceived success on like the same behavior. So they watched the same thing, but care providers perceived the success of the robot to be lower than students did. So there's definitely going to be differences, and I think a lot of that can be attributed to their experience. For example, they know the risks of providing medication and like dispensing the wrong medication, so they might have more grounding for the risks involved, and maybe that shapes perceived success.
I see.
So
Would you say they trust the robot less?
they might. I don't remember if we found that in that study. I should probably go check. I don't think so. I think the only difference that we had observed there was the perceived success. And what was also interesting there is that despite perceived success being lower with the care provider population, we had this metric where we allowed them to sort of emergency stop a robot and just say, this is an intervention. I'm not going to allow you to continue forward. And despite the lower perceived success, there was no difference in intervention rate. So it definitely begs the question of like, they might be perceiving this differently and maybe a bit more critical on the performance, but why wouldn't that translate into then more intervention? There might be space there to empower the care provider to intervene. It could be because they had lower experience with technology, where I work at a technical school, and so there's a lot of background in computer science and some in robotics. So that could have played a role, but it would be very interesting to just look at aligning intervention rate with the perceived performance of the robot.
This is me just guessing, but one of your studies also said that being physically close to the robot also influences trust. So maybe
It does.
if the care provider was physically present with the robot, it might have led to fewer interventions.
Yeah. So in the study, so this was a study run during COVID. Otherwise, we would have had care providers in person, but because they were working with the older adults, we didn't want to have that exposure during COVID. And so because we were worried about that, it was actually quite a complicated study design. So we had the desire to run care providers, but we were going to do it remotely. So we compared them to remote students, and then we compared remote students to in-person students. And so we tried to isolate the impact of being remote versus the impact of being a care provider versus a student. And so that's like one of the examples of like how you have to design a study when you're working with the population and it's COVID and you don't want to expose them. So yeah, I mean, students either, but the stakes of being a care provider was really important.
And what were the results of the findings?
So actually, being in person seemed to improve perceptions of safety, usability. So it seemed to actually, people would have more favorable perceptions when they were in person compared to being remote, which to me was kind of surprising because for context, when the robot was cutting the banana, it was a real knife, sharp knife. They were 8 feet away, so they were safe. But to me, you would think you're in person with a robot cutting, with a true knife, long knife. I would have assumed that being in person might have made that interaction more risky and maybe more frightening. But actually the perceptions were overall much more positive in person. So this could be actually really nice for the studies conducted during COVID, primarily virtual. Maybe it indicates that they would be perceived more positively in person.
Do you fear over-reliance if other robots are physically present with you and you don't intervene when you should be intervening?
I fear over-reliance. I think that's one of the places that would definitely be interesting for future work is finding ways to calibrate trust, calibrate reliance so that it's, it's not on either extreme of like, I trust anything the robot does and says, or I trust nothing and will do it all myself. I definitely think that once again, there's a Goldilocks area in the middle there that would be helpful to get to.
Again, another guess. I think it really comes down to your perception of the robot. You're a roboticist. You know that robots can screw up, but say I'm an outsider and I see this really cool device in the laboratory doing cool things. I don't know. I would feel like a lot of smart people have programmed this to work perfectly.
Mhm. Yeah, because an experimenter is there.
Exactly.
Right. So that's the question. And there's a lot of work on this is the impact of the physical presence of an experimenter and sort of this knowledge that someone designed this. So like surely it can't go that wrong. And so I think it'd be very interesting to rerun all studies in a person's home with no experimenter and sort of compare the differences and see what holds, what changes, what gets more strong in terms of impact and significance.
Do you think the only way to validate this is by moving away from the lab into people's homes?
No, definitely not. I think that there's a place for experiments that are conducted in the lab, especially like the first iteration of a study. I think it makes a lot of sense. But I do think that more either true, like this person's home, that's where we're going to take the study, or a home setting that isn't a laboratory setting with other studies going on and other distractors. I think that there's definitely, it would benefit the field to do more of that. But the reason that's not very common, it's quite costly, it can be risky for the the physical safety of the robot and of the person. I'm sure the process of getting an IRB approved for that is very different. IRB is like you're making sure that what you're going to do is ethical, and there's like a review process to make sure that the plan for your studies has been reviewed and is safe.
So there's a place for experiments conducted in the lab and at homes.
And it definitely depends, what are the concerns with it being in the lab? There's so many different studies that can, it depends on what you're studying and what you think will be confounded by having an experimenter present. You can also take a first step by taking the experimenter and putting them in a different room or behind a barrier, and you can even compare in the lab with and without the experimenter visible. So there's definitely things you can do to mitigate if you want to stay in the lab. There's also facilities. So Georgia Tech, which is where I go, Georgia Tech has something called the Aware Home. It's a research facility, but it is a home. It's a home space. So it looks like a home. It's designed, it's furnished, and you can run studies there. And that's a really great in between where it's still on campus. You still have the support of the school, but it feels like a home setting.
I think a lot of work goes into designing good experiments, especially in the field of HRI. Can you break down some of the guidelines that researchers in this field follow to design compelling experiments?
Hmm. Yeah, it's you could take a whole course. There are courses. They're fantastic on this. It kind of follows a scientific method. It does. So you just need to think first, what am I interested in measuring and what are my research questions? And what is sort of the minimum interaction with the human that would representatively, that would capture what I'm trying to measure. It's really easy for studies to get long and get out of hand in terms of design. You first bringing them in, you have to introduce them to all the concepts that are relevant, make sure that they understand what they need to then go into that interaction. And so I think being cognizant of the impact of having a very long study and what that will do on their perception of the interaction is really important. And if you get greedy and you want to measure a lot of different things, there are definitely designs that will allow you to break that into pieces. You don't have to throw all your research questions on the same person. One of the big things you can do is decide whether, if you have multiple conditions you're comparing, whether the same person has to experience all those conditions or whether you can have different people experiencing different conditions. It changes your analysis, and there are cases for both. So those are the major ones. One thing that you do when you're designing a user study is you go through that IRB protocol. So you write up everything you're going to tell the person, every metric you're going to collect, every survey you're going to administer, and you write it all up. And it's really helpful because that way you are more consistent when you're running the study. So you end up running many, many hours of the same process. And it's a pretty unique experience, at least it was when I started running them. And so you have to be very patient and willing to go through the same routine over and over. But it's so fascinating because despite what should be a very similar process, people are incredibly diverse, and every user study you run is going to be very different. And seeing the differences in how the same instructions are perceived is really fascinating.
I know a lot of students make this mistake early on, but they get greedy, like you mentioned, in terms of the
Mhm.
number of research questions that they want to answer.
Yeah.
So I think what you've done really well, and it's a sign of an effective PhD student, is narrowing the question down and
Mhm.
designing the study very, very
Yeah.
carefully so you can repeat whatever you do over many user studies.
Thank you.
You're welcome. But how have you managed to go through this process? How have you realized that okay, I need to be better about scoping my research questions? What are some strategies that you use?
Well, it's not unique to running user studies. This is the plight of researchers generally. I think there's a lot of interesting questions out there, and especially in the case of interactions with an end user, that time with them is so rich and there's so many things that we're curious about, and so it's difficult to feel like I'm only collecting these two surveys. I could collect so many more and think of all the analysis we could do. So I think it's not unique to HRI. Um, I had the good luck of coming into a lab that had a lot of senior researchers that were willing to let me sit in and help run studies. So I got a lot of mentorship early on, which was really great and very helpful. But yeah, scoping, I don't know if there's really one answer for how to do that well. Maybe some people do it different ways. I like to write pretty early in the process. So when you're doing research, you have coming up with the idea, executing, and writing, and they don't have to necessarily be in that order. Though traditionally it is, because you write, then you publish, and you sort of share it with the world. I like to try to get my thoughts in order earlier. So as I'm coming up with the idea, I'm often writing the introduction of the paper, or I'm writing the methods of the paper, and I'm seeing, are all my decisions that I'm making in this user study, are they supported by literature? Is there a reason, or am I just sort of making a shortcut here with what I'm deciding to do? And writing early can be really helpful to identify those gaps and those holes. And then the other thing is I just talk to a lot of people. It can be really helpful to try to explain an idea kind of like an elevator pitch, though I hate elevator pitches. It can be helpful to have to share within, a brief amount of time, because you synthesize what the most interesting part of the study is, and maybe that helps you focus on just that.
So you feel talking to people helps explaining your thought process?
Research in isolation, not for me. I'm impressed. I see like single author publications, and different fields do it differently for sure. The best part of research for me is that it's not something that's just done at my desk by myself. Yes, there's that part, and it's very important, and it can be really rewarding, but it's the connection with other people, and you come in with these different ideas, and you get surprised with, yeah, it's the best part for sure.
You're gonna hate me for this transition, but I will make it anyway. Do you feel that, self explanations make you a better robot teacher as well? For example, once you're done teaching the robot and I ask you to explain your thought process behind why you did something, it might help you be better at breaking tasks down into their individual components.
I've not evaluated whether that's the case. Part of me wants to say yes, because being forced to reflect, surely that has to help. But I'm not convinced that it has to be verbalized. I do think that process should exist, but I don't know if necessarily verbalizing is the only way. The reason I say that is because there's some literature that says that some people struggle to explain what they want the robot to do, for example, and how they want it done. Like, I think showing can often be much easier than explaining or telling or instructing. It's definitely scenario dependent, but in a lot of the cases that I've experienced, it can be much easier, especially when they're physical manipulation. You just want to sort of show the difference that you mean.
Yeah, we are better at doing than explaining. It's pretty embedded in the way that we just are as humans.
That does sort of rely on the fact that you can show, though. And I don't know if that's always the case. Like, there are definitely instances where you either can't show because of the task, or maybe because of your own, if you have mobility limitations or something. And so I think that, yeah, with that caveat, that like if it's something that you can show reliably, repeatedly, with the body that you are given, like maybe you're not strong enough to lift something. So it definitely depends.
Understood. Do you think that having an interface that allows you to break things down break that long sequence down into subtasks helps people rationalize their own demonstrations better?
Maybe. I think it's the way that, so when we run these studies where we're asking people to break it down, we do make an interface, we provide it to them, we teach them how to use it, and then that's the process that they go through. I do think that there's wiggle room there. I think that there are other ways that they could give that information to us that might be more intuitive or less work. That's just the one way we've tried so far because it removes the experimenter from being constantly involved in the process. And I like the idea because it means that maybe this could be something that could be done without an experimenter in their home if it's really their sort of their purview. But interface design is a whole field on its own. And so I think that maybe there are definitely a lot of areas in which our interface could be improved. And so I hesitate to say that our interface design makes the teaching better because I think our design could be improved for sure. I do think that maybe it provides more pauses in the teaching to have time to reflect on what they're doing. And because they have to label every demonstration that they provide with a name, maybe that also forces them to sort of summarize, okay, what am I doing? And see all of those stacked together in the same place and then using those. I do think that that can influence the process, forcing them to summarize what they've done, not only show, but give some sort of name. So I guess in a way that there is this verbal and there's this demonstrative.
Yeah, yeah. So I know this is a general question, but what are some of the features that you would want to add to an interface to make it easy for robots to learn from demonstrations?
Hmm. So easy in the sense to teach the easy for the human to use or easy from the robot side?
Now that I think about it, both actually, and more so making it
Mhm.
easy for the human to teach the robot.
Yeah, because when like the interface is like a middleman between the demonstration collection and the packaging of that data. So I would say the interface doesn't influence as much the robot learning process as long as you're saving the right data for what you're doing. But from the human side, interface design can be pretty important. There's a lot of phases when you're teaching a robot. So the first phase that we like to give is just first, let's do planning. Think of all the things you want to teach the robot, make a list of them, and write those down. Just the names. You don't have to show me anything. Just like I'm going to show it how to do like a fork, and then I'm going to show it how to move a plate or whatever your skills are. List them out. Think about what you're going to do before you get started. And I like that because that's how I am. Like that's the type of planning that I do. I want my list of things I'm going to do, then I'm going to sequence and actually do them. And it helps me know how they're going to work together to have them listed like that, as opposed to just doing one and then doing the next and not really thinking of the puzzle that they're going to be in. Then there's actually teaching each piece, physically demonstrating each one. And then there's actually using them to accomplish a task and maybe a couple tasks. So you might chain them, you might specify more information about how they should be used. And so because of those three different phases, each requires its own page, and it can be a little bit difficult to navigate, okay, where am I in the teaching process? What part do I want to do now? And how do I want to evaluate what I've done so far? So I think that in designing the interface, trying to streamline and make it intuitive where they should live at that current time would be something that I would think is really important. That's something that we've tried to focus on in our research for this interface design, but it's not something that we've compared against prior works. And there isn't really a standard interface for LFD. So we're thinking we might publish the next one that we make just so that there's something people can then iterate and improve. It would be really nice to not have to create an interface or use just the one your lab uses. There might be one out there, but I haven't seen one.
How could you potentially measure if an interface is better than the other? Seems very subjective.
Yeah. So you could have people, okay, because you probably would want the same person to use multiple interfaces for very similar or the same task. Yeah. And then I think a lot of it would be how they navigate it, how they felt about using it. If it's the same task, you're not so much going to look at the quality of the demonstrations. I guess you could, but that is kind of separate from using the interface itself, like how you're going to move the robot, how you're going to operate it.
And it doesn't even have to be reported uh, in terms of how I felt using it, but how you behaved. How much time did it take you to teach the robot?
Yeah, how many questions, how much time, how many times did they have to like undo and redo something? And so we do track all of that in interface usage. Every button is sort of logged. You can sort of see the ordering of things, especially when we give feedback through the interface, or you can say like, okay, here's what I taught, evaluate, and then there's different feedback you can get. Where you look at, okay, did they make changes based on that feedback? What type of changes? What was the feedback saying? So there's a lot of tracking going on, and definitely there could be some analysis about perceptions and
And also another thing is, so we talk about humans and
mm,
our ability to teach the robots, but there are also different types of robots. Do you think there could be one common interface for all of these different types of robots, or
hmm.
will we have to start separating them out?
Yeah. So that is a question I've been thinking about recently because we've been using more or less the same interface. We've been improving and developing, but we've had sort of a core in my lab for multiple studies, but it's always been one-armed robots, or at least the arm, there's only one arm that people are demonstrating the task for. And we're shifting to a study where we're going to have a bimanual, so two arms. And I think that shift will require some changes in the interface potentially if we want to have someone only move one arm at a time. So there's so many different ways. It depends on how you're actually providing those demonstrations, like I mentioned. One option is to have a rig where they have both arms moving and they can move both arms of the robot concurrently. And there are benefits to that. There is also the option of freezing one arm. They may walk around, move one arm, leave it, walk to the other side of the robot and move the other arm. If you're breaking it up like that and you're freezing one arm's movement at a time, I think there could be some interface design around making that clear. That said, I do think that you could just have one interface for multiple different morphologies because, like I said, you can sort of just push record and then the demonstration process is kind of isolated. You'll have a tracking of what the person does in terms of the joints that the robot is moved in and the camera feed, but that recording process can be sort of separate from the interface design. So yeah, I think you could just have a backbone that's shared at least.
I do want to talk about some of the challenges and future directions moving forward. So you
Yeah.
are considering a lot of these open questions, but I'd be curious to know what are the big barriers that's preventing a lot of these studies that are happening in labs to be deployed in real homes with caregivers and older adults so that
Mhm.
we can conduct a lot of these long horizon studies.
Yeah, I think you captured one of them there, and it's long horizon or longitudinal studies. So, lab studies, they last a few hours at most, and some of them you come in repeatedly, but one area of evaluation that isn't as common because it's quite costly is so longitudinal deployment of a robot. So you actually put the robot in the home and you leave it. The definition of longitudinal can vary. Some people it's a week, some people it's like a few months, and some people it's actually like a year or more. And there's definitely literature that shows that the use and interaction will depend upon how long the robot has been deployed. There's like a period where you're getting used to having the robot there, and it changes how the robot is used and incorporated socially and operationally. So it's actually really interesting literature, the different phases that people go through when technology is adopted. So there's like phases where they don't know how to use it yet. There's phases where they're showing it off to their friends and like to other people, and it's becoming more and more incorporated in the routine. So there's different phases. And because there is this impact of how long it's been deployed in the home, it'd be really great if more studies were looking at longitudinal deployments and actually seeing how that affects whatever their independent variables are. So that would be one area, definitely. Mm, let's see. The question was opportunities for future work and barriers.
Yeah, I feel this still seems a little far out. How far are we from, actually conducting these longitudinal studies?
There are some, for sure. There are some with simpler robots, like the Roomba. There's been some longitudinal studies with the Roomba. So there's definitely some. There's also other robots that have been deployed longitudinally. Maybe their functionality isn't wielding a knife in a kitchen, but we can characterize some of the adoption behaviors for sure. I think it's not as far as you would think, but it definitely is task dependent. It also changes the scale of your study. So if you're doing longitudinal deployment, you're probably not running very many participants. You might run 5, and then it's for many months at a time, and there's other family members are involved, but it's sort of 5 homes now. But I think that it's definitely feasible. It just depends. Research is often driven by the values of the conferences and journals that that field submits to. And so it depends on whether the field in question values fewer people and longitudinal deployments, or if for that research question, it's more important to have a higher volume in person. And I think those are complementary. So it definitely depends on also whether the lab can go without that robot for many months. And not every lab has the luxury of having a series of the same robot or a series of robots to do studies on. And so it's definitely an investment in time and yeah, it's an investment in resources for sure. And you have to make sure yeah, the robot is still functional and working, hasn't just been abandoned in the corner of the house. So it's a very different study design, and I look forward to running longitudinal studies and seeing how the study design has to be changed, how frequently to check in, what that check-in looks like to not disturb the deployment.
There seems like a lot of work has been done prior to this, but there's also so much coming up very soon. You've spent about 5 years in your PhD. I'm wondering, after your undergrad, what was your mental state in terms of, the kinds of problems that you wanted to pursue and what attracted you to HRI in the first place?
Yeah, I'm a believer in not necessarily knowing everything on the start in terms of what your interests are. When I first started my PhD, I was convinced that I was going to be writing algorithms for foster care, which I'm still very interested in. I was talking with a professor, Radet Abibi, I believe she's at Berkeley, and we were talking. We had this data set of foster care data in California, and we were going to sort of see what we can improve. She does a lot of uh, network design and analysis. So I started there, and I was just starting off with a class on sort of robotics at Georgia Tech. And the professor, Matthew Gombolay, who is now my advisor, just put out an announcement saying one of his students needed help running a study. And I thought, what the heck? That sounds so interesting. It's one of those things you see in movies where people come into a lab or to an office and they get their behavior gets studied. So I helped with that, and then that was that. I was hooked. Yeah, I'm also a big believer in enjoying the process. So there's the motivation of sort of at a high level, do I value the things that I'm working on? Do I think they're important for the world? And there's also, am I enjoying what I'm doing day to day? And for me, human robot interaction, the field, running studies, designing studies, and reading papers, every day felt very enjoyable. And I think that that's probably difficult to find in most jobs. It's just the feeling of what you're doing on a day to day is very rewarding. So, yeah, it helps get through a PhD, I guess.
Yeah. How do
Yeah.
you make sure that that feeling still continues? You're going to be done with your PhD soon. What are
Mhm.
some plans that you have to take this forward?
Yeah, I think the feeling will definitely, I mean, I hope it will be there. I think the work will change. I'm hoping to go into academia. And so my responsibilities will shift more towards mentorship, which I'm very excited about. My parents are both teachers. And so there's been a lot of emphasis on mentorship and teaching and sort of, helping the youth. And I'm very excited about that prospect. It also means a lot of collaboration with the students that you work with other labs, with other schools. And as I mentioned, I love the collaborative aspect of research. So I'm very curious and very excited about it. It is interesting because when you get a PhD and then you go into professorship, it feels like such a jump. Like the responsibilities change pretty dramatically. And I've heard a lot of people feel like they weren't prepared for those aspects of professorship, like grant writing. You don't get much experience with grant writing. Not every PhD student has the opportunity to mentor masters and undergraduates and lead PhD teams. So I'm very curious and very excited to see what that transition will be like. But excited, yeah.
Yeah. Looking really ahead, and you don't have to have an answer, but what is the kind of impact that you would like to have in the field of HRI?
It's tough. It's tough to say because I think the scope will change naturally. I hope that I can run a lot of studies that are in people's actual habitat and show whether or not these things will work in the real world over a long period of time with real users. And ideally, I'll be able to improve the systems we're developing so that people can age in place with less loneliness, more support, physical, cognitive support, that we can alleviate some of the burden, the burnout on care providers, and see whether robots have a place in that care network and what that would look like and how the interaction would be with the different stakeholders of the care network. That would be a really amazing if I could have that impact. And it doesn't have to be just aging in place. I'm very motivated by meeting people where they're at in terms of their understanding of the robot and abilities with the task. And that goes beyond aging in place for sure.
This is a great place to conclude the conversation. I
Yeah.
just wanted to say that, I feel because of the fact that you really enjoy the process and you have clear values in mind, it really comes through in the sincerity of the work that you put out.
Thank
Uh,
you.
and, it's inspiring for other viewers as well. I'm sure that this conversation will have an impact on other researchers on campus and beyond.
Yeah.
So I'm very grateful that you give me the opportunity to speak
Yeah.
to you.
I
And
enjoyed it. I love
yeah,
talking about research. So, yeah.
I'm glad. I'm glad.
Yeah.
I wish you the very best. Thank
Thank
you.
you.